Hello everyone, I'm back with my next lesson. So I'm on chapter 7. This is 7-3. So we are solving system of equation. Solving system of equation with three variables. Okay. Yeah, you guys might gonna say we have done this before, but before we did it by elimination and substitution. Now we're gonna use matrix algebra to solve system of equation with three variables. Like you'll see three equations like I have x minus 2y plus z, it's equal to 7. 3x minus 5y plus z, 14. 2x, 2y minus z, and it's equal to 3. All right, step number 1. Let's just change all these equations into matrix or matrices. So first matrix, since it's 3 by 3 or 3 equation with 3 variable, so first equation is going to be my 3 by 3 equation with just the coefficients in there. So I would have 1, negative 2, 1 from the first row. Second 3, negative 5, 1, 2, negative 2, and negative 1. Okay, keep in mind, let's say if there's any variable missing in any of the equation, just put 0 for that. Don't just leave it blank. I want you to put 0 for that missing variable. All right? Okay, then we need our next matrix, which is going to be 3 by 1 size, and I would put all three variables in there. So I would put x, y, and z, and the matrix on the other side would also be 3 by 1, and I'll just put numbers in there. So numbers I see on the right side, I'll just put it in there. All right, I'm done setting up my equations in matrices. Now next is basically just like 2 by 2s. So this is what we are solving for. So in order to get rid of this, in order to cancel this, what I have to do is I have to divide by this matrix. And I hope you remember, we don't divide. Instead, we find the inverse. So technically, you need to find the inverse of this matrix and put it on this side. Okay, so now this is where you need to go back to, I would say, Monday's video. Yeah, that's when we did 3 by 3 matrix, finding inverse of 3 by 3. So pretty much what I have to do is, so this x, y, and z would stay on this side. You already have this matrix already on the other side. Remember, there's a way you need to put all these. So I would actually put inverse. So inverse first. So it would, hold on. So it would be inverse here. And the other matrix would go here. So what is the matrix? 7, 14, and 3. 7, 14, and 3. And for the inverse, I hope you remember it's 1 over determinant and adjoint matrix. Now this is, again, you need to go back, you need to teach yourself or look at your notes, whichever way makes easier for you, just do that. Please try refreshing that whole process first. So how do we find adjoint and determinant? So I'm just going to write that 3 by 3 matrix here so that we can actually follow all those steps down here. 1, negative 2, 1. 1, negative 2, 1. Then I have 3, negative 5, 1. 3, negative 5, 1. Then I have 2. Is it 2? Yeah, 2, negative 2, and negative 1. 2. I have 2, negative 2, and negative 1. This is my original matrix. Now I need to find minor matrix. Minor matrix is where you need to find, or you need to replace every number in the original with its minor. So how do we find the minor? So let's say I'm looking for minor for this place. So I would cover the row and the column it's in. Once I see this 2 by 2, find the determinant, it would replace the number. So determinant would be negative 5 times negative 1 is 5. Minus negative 2 times 1, it's negative 2 would become 2. And this is 7. All right, next one. I'm just going to show you one more, and then rest pretty much I already have those done. I'm just going to copy those. So let's say if I'm looking for minor for my second number, which is this here. So I would cover the row, or let me use a highlighter. It would be easier for you. I would cover the row and the column. So whatever 2 by 2 I see 3, 1, 2, and -1. So find the determinant. It would replace this number here. So 3 times -1, -3, minus 2, it's -5. And rest, I'm just going to copy those off from my notes. I have 4, I have 4, another 4, -3, 2, 3, -2, and 1. All right, that's my minor matrix. All right, so the next one is cofactor. Cofactor is where you put the sign pattern. So the sign pattern is, I don't know if you remember, we start off with plus, minus, plus, minus, plus, minus, plus, minus, plus. All right, it's basically multiplying every number by the sign assigned to it. So I would have, after simplifying, I would have 7, 5, 4, -4, -3, -2, 3, 2, and 1. These are my cofactor elements. The last one is adjoint. How do we find adjoint? Basically, it's just, hold on, yeah. So basically, adjoint is when you replace or you interchange rows with columns. Okay, so my rows with columns. So the one you have it as a row, now it would be your column down here. Let me pick a different color. So let's say I have 7, 5, 4. Second row would be my second column now. Third row would be third column. Here you go. That's my adjoint. Now the only thing I have to do is the determinant. So determinant is when you pick original row and you multiply by the minors. Or if you remember, I said you can multiply by the cofactors, then you don't have to follow the sign pattern because I already put the signs with those numbers, right? So I'm just going to pick my first row. I have 1, 2, 1. I'm going to take my cofactors, 7, it's -2 here, my bad. So I have 7, 5, and 4 since I already put the signs there. So again, I'm just going to add these. So it would be 7, 10, and 4. If I simplify, this is 1. So determinant would be 1. So let's just say 1 over 1 here. Almost there. Now go back to my equations. I have x, y, and z. So you know this is going to be equal to 1 over 1, which is the determinant. My adjoint, which is 7, -4, 3, 5, -3, 2, 4, -2, 1. And the matrix on the other side, which I already know, it's 7, 14, and 3. All right, I'm almost there. One last step. It's multiplying by this determinant to this inverse matrix. This is the determinant one. This is the inverse. And these are the numbers on the other side. Okay. Remember I told you don't multiply by the determinant first because then everything's going to become a fraction, which is not going to be easy to simplify later on, right? So I would multiply these matrices first. So if I multiply these, again, I hope you remember insides are same. Check mark. So 3 by 1 means it's going to be 3 rows. 1 column, so let's multiply first number by first, second by second, third by third, and add them all. So 7 times 7, 49, -4, 14, 56, 3, 3, 9, 5, 7, 35, 42, 6, 28, 28, and 3. Let's simplify. I have x, y, and z on this side, and if I simplify all of these, it's going to be 2, -1, and 3. It's 1 over 1. And if I divide by 1 or multiply, it's still going to be the same thing. So finally, my answer is this one here. So for x it's 2, y is -3, and z is 3. Yeah, this is pretty much all. So thank you for watching. If you have any questions, please send me a comment and then I'll answer that.